Servo motors are a special type of motor. They are not like regular motors that just spin freely. Servo motors are designed to move to a specific position and hold that position. Imagine a robot arm. The precise movements of that arm are often controlled by servo motors. Servo motors are used in many different applications, from robotics and automation to cameras and model airplanes. They are essential for tasks that require precise control of movement. Think of a servo motor as a smart motor. It knows where it is and where it needs to go, and it can move very precisely to get there. This makes them ideal for a wide range of applications. Imagine you have a door with a spring that always tries to close it. To open the door, you need to pull it open against the force of the spring. Servo motors work in a similar way. The servo motor receives a signal that tells it what position to move to. This signal is like your hand pulling on the door handle. Inside the servo motor there's a mechanism that acts like the spring, always trying to return the motor to its neutral position. The motor then rotates to overcome the spring and reach the desired position. Once it reaches the correct position, it holds that position until it receives a new signal. A servo motor consists of several key components that work together. The motor provides the rotational force to move the servo. The control circuit receives the position signal and tells the motor how much to rotate. The potentiometer is like a sensor that tells the control circuit the current position of the motor shaft. Gears are used to reduce the speed of the motor and increase its torque, allowing it to move heavier loads with precision. These components are all housed within a compact casing, making servo motors a versatile and easily integrated solution for various applications. When the control circuit receives a position signal, it compares this signal to the current position of the motor shaft, which is measured by the potentiometer. Based on the difference between the desired position and the current position, the control circuit sends a signal to the motor, telling it which direction to rotate and how much. The gears then translate this rotation into precise movements of the output shaft. This process continues until the desired position is reached, and the potentiometer confirms to the control circuit that the servo has achieved the commanded position. Section 5. Servo motors in action. Real-world applications. Servo motors are used in a wide range of industries and applications, including robotics. Servo motors are the muscles of robots, providing the precise movements needed for tasks such as welding, painting, and assembly. Manufacturing. In factories, servo motors are used to control the movement of conveyor belts, robotic arms, and other machinery. Consumer electronics. Servo motors are found in cameras, printers, and other devices where precise control of movement is required. These are just a few examples of the many ways servo motors are used in our everyday lives. Section 6. Advantages of servo motors. Servo motors offer several advantages over other types of motors. High precision. Servo motors can achieve very precise movements, making them ideal for applications where accuracy is critical. High torque. Despite their compact size, servo motors can generate a lot of torque, allowing them to move heavy loads. Closed-loop control. The feedback mechanism provided by the potentiometer ensures that the motor always reaches the desired position. These advantages make servo motors an attractive choice for a wide range of applications. Section 7. Limitations of servo motors. While servo motors offer numerous advantages, they also have a few limitations. Cost. Servo motors are typically more expensive than other types of motors. Complexity. The control circuitry and feedback mechanisms of servo motors can be complex, requiring specialized knowledge to operate. Limited rotation. Most servo motors have a limited rotational range, typically less than 360 degrees. Despite these limitations, the advantages of servo motors often outweigh their drawbacks in many applications. Section 8. Conclusion. The future of servo motors. Servo motors are essential components in many modern technologies, and their importance is only going to grow in the future. As robotics and automation continue to advance, the demand for precise and reliable motion control will only increase. Servo motors are uniquely positioned to meet this demand, making them an exciting field within electromechanical systems and devices.